This is one of the most important building materials in America. It wraps the walls, floors, and roofs of millions of homes across the country. And for decades, it's been made the same way, out of slow-growing trees harvested at an enormous industrial scale. But inside this factory in North Carolina, a startup called Planted is proving it can make the same product out of something that grows a lot faster: grass.
You could actually watch it grow. If you sat here long enough, it'll grow about 6 inches a day.
The American housing industry runs on wood. Walk through any home build site right now, and you're basically walking through a lumberyard, with 94% of single-family homes in the US made out of wood framing. But that supply chain isn't exactly stable or sustainable. One trade dispute with Canada, one devastating weather event, and the cost of building a home can swing by thousands of dollars. Planted thinks they've found the fix and has already sold 10 million of its structural panels to the biggest home builder in the country.
The goal is to take over the lumber market, which means the way that we build now, the way that we produce material now, the way that we build our cities of the future has to change.
But if lumber built America, can grass really replace it?
They don't want to buy anything unless they can get it next month. So until I'm at capacity and I'm actually producing the numbers that they need, they won't buy it.
I flew to North Carolina to see for myself how Planted is turning this into this, and to find out if it can scale fast enough to outcompete lumber and get the rest of the home building industry on board. So this is my first time in North Carolina. There are a lot of trees here. Do you sense the irony of that a little bit?
I do, yeah, and it's kind of interesting because a lot of folks ask why North Carolina.
Yeah.
And what's really interesting about that is everything grows here.
This is Nathan Silvernail, CEO and co-founder of Planted and ex-SpaceX engineer. From 2014 to 2021, he helped build two of SpaceX's most important vehicles, the reusable Falcon 9 rocket and the Crew Dragon capsule, designed to reliably deliver cargo and astronauts to space. But eventually,
I got to a point at SpaceX where I realized I didn't think that the problems that I was trying to solve really helped humanity. It was cool and I loved it, and I think it was really interesting and it helped me learn a lot, but ultimately it didn't sit right with me at the end of the day.
Nathan's co-founder, Wada Tan, was also an engineer at SpaceX at the same time. After briefly retiring in 2021, Nathan wasn't looking to build a specific product or disrupt a specific industry. Instead, he was looking for the most complex problem he could solve for the betterment of the planet. He already knew that building materials accounted for a large portion of global carbon emissions, but the idea to create an OSB alternative that could rival lumber? How did you land on that?
That was actually my co-founder. He was driving by a site one day, a construction site. He got out of his car and talked to the builders and kind of asked their opinion. If I were to come up with a much better version of this, what would you think about it? And it kind of just took off from there.
OSB stands for Oriented Strand Board. They're the structural panels that wrap the walls, floors, and roof of a home. Not the studs or beams you might be picturing, but the large flat sheets that go on top of them. Planted's initial production process was scrappy, but it successfully caught the attention of D.R. Horton, the largest home builder in the US. They commissioned Planted to build an actual house out of its OSB alternative and prove it could pass permitting. Once it did, Planted raised a $10 million Series A and locked in a contract with D.R. Horton to produce 250,000 panels, enough to build 1,000 homes. But even with those early achievements under its belt,
it's a very difficult problem to solve. There's the biomass, there's the manufacturing, and there's the business economics. You have to solve for all three in order for the whole machine of this idea to work.
Each one of Planted's panels starts in a lab. So they're growing, and then you're just dividing, and then they grow, and then you divide, and then...
Most of the time it's cutting them in half. Sometimes you will get some that, Terrell's working on some right now. He's gonna get 3 out of some of those.
This is Dr. Janelle Olitz, a soil expert and Planted's director of agriculture, who helped lead the company's 6-month search to find its carbon sequestering biomass, a perennial grass that's been grown in North America for hundreds of years and used to make all sorts of products: fishing poles, baskets, and even the reed in your middle school clarinet. But Janelle says it's especially good for building modern homes because of a natural compound called lignin.
When it's fresh out of the field, you can't break that.
Yeah.
But the same, a piece of pine of the same diameter I could take that twig and just snap it in half.
I did feel it on the floor. It's very hard to break.
Yes, and so that lignin lends itself to the same rigidity you're gonna have in a board.
Because it grows so fast, it can be harvested twice a year, whereas softwood trees, like pine, can take 40 years before they're harvest ready. And that means
The carbon sequestration rate of this plant is 9 times higher than trees. So you get a really amazing land efficiency increase when you switch from an acre of pine to an acre of this.
right now, Planted Supply is being grown less than an hour from its production facility in Oxford, North Carolina. But the idea is to build future facilities right next to the farms, which would simplify a supply chain that's traditionally complex and, according to Nathan, only makes sense with trees.
When we're looking at the material itself, it was, wait a second, if I didn't have to use trees, would it still make sense? And the answer was no.
Okay, wait, pause it right there. That concept of a modular system that sits right next to the supply chain, that's the ultimate moat. Most founders think you need billions to build this kind of infrastructure, but it's actually about the model. Our team spent weeks breaking this down into a free resource called 7 Infrastructure Businesses You Can Build in 2026. It's not just ideas. It includes the execution templates and funding worksheets you need to build something defensible, like the alternative supply chain model Planted uses. If you want to stop chasing trends and start building leverage, click the link below or scan the QR code on your screen. It's totally free, but the execution models in there are worth thousands. Traditional OSB manufacturing typically starts with dozens of trucks transporting thousands of tons of logs to a woodyard, where the bark is removed and oftentimes burned to create fuel to power the production process. The machines involved in that process can be hundreds of feet long and multiple stories tall. Planted's process, by contrast, operates on a much smaller scale on purpose and doesn't require burning raw materials for fuel because it's electric. The full production line doesn't run every day, but Nathan says it's capable of producing 250,000 panels a year, depending on how much raw material is available. That's these pieces called billets. The process starts by feeding them into a machine called the chopper.
Yeah,
What is it called?
the strander.
The strander, thank you. Thank you for the technical term.
The machine just has a series of blades on it that rotates at a specific speed. They have a specific prominence that gives us very specific morphology of the strands coming off of the billets. So once it's finished there, it'll actually go up the conveyance system and then make its way into the downstream side of the processing center. This machine actually sifts it, so we'll take out the large chunks. Every now and then we'll get a rock or two, maybe a bolt will fall off somewhere along the way. We sift all of that out, and then we also sift out any of the fines or the smaller particles that we don't want in our panels.
From there, the best strands for each board are dried and then sorted onto another conveyor that portions them out so that each panel has the appropriate density. Next, they're mixed in this massive blender with resin, the binding agent that holds the panel together. It's a simple recipe that requires just 2 ingredients and a lot of heat.
And then it'll actually go into the main section of the press, where we'll take that mat, start applying the pressure, start applying temperature for a very specific duration of time, and allow it to form the thickness that we're looking for, form the strength that we're looking for, and then ultimately get that initial cure.
What comes out on the other side is a standard structural panel that's 2 times more moisture resistant and 1.5 times stronger than traditional softwood OSB. That's according to Planted's own internal testing. But the panels have also been independently certified as a direct code-compliant alternative to standard OSB, approved for use in all 50 states. Planted refers to this entire production line as the machine. Almost every piece of its hardware was built in-house. Eventually, Nathan says this space will be used primarily to build machines, not panels.
Similar to SpaceX, we vertically integrate everything that we can. We have our own engineering team, we have our own manufacturing teams, we have our own manufacturing machine shop. The idea is to miniaturize, electrify, and compartmentalize that entire machine, and then just spit panels out right at the farm that then go to housing developments that are also nearby.
So, if I were to walk into like a traditional OSB mill, how would it look different than what you have here?
A full-size manufacturing mill is going to be the size of a neighborhood. It costs around $500 million to make, 5 years to actually build it. 6 months to turn it on. And like I said, once you turn it on, you don't want to turn it off. So if they have a material disruption, which they often do, and they have to shut their mill down, then they have a $500 million complex that's effectively generating no revenue, no panels, no anything.
For the lumber industry, material disruptions aren't hypotheticals. Take, for example, the major storm that hit British Columbia in November 2021. According to one lumber analyst, it stopped shipments by a good 20% and 100% in certain places. That same month, the US doubled its tariff on Canadian softwood lumber imports. And together, those events, plus others, sent lumber prices surging. More recently, we've seen prices spike based solely on fears surrounding President Trump's looming tariffs on Canadian softwood lumber.
And in fact, we just saw today that futures for lumber at their highest point since the election. So the volatility has already started to take place in that market.
If it wasn't clear from those examples, Canada is America's biggest softwood lumber supplier, making up 85% of imports. But according to Planted, the bigger problem isn't lumber prices or supply disruptions. It's how the lumber industry decided to utilize a raw material it never wanted in the first place.
They had to effectively come up with a way to take that lumber that's no longer 3 feet wide, right, 4 feet wide, and make it 4 feet wide. So they're just like, let's break it all down and glue it back together. That's how OSB was made.
The American lumber industry is as old as the country itself, but the category of softwood lumber, and oriented strand board specifically, is relatively new. The product evolved from wafer board, which was invented and patented in 1965 as a cheaper alternative to plywood. But both products were workarounds, ways to make use of what the industry had left after centuries of cutting down its own supply.
The machines that they had utilized in order to make lumber at that point in time really could only be utilized on these huge trees. And so they invented oriented strand board as a way to utilize baby trees effectively. So when you look at a tree's life, especially pine, we can take pine for example, the first 15 years, it really doesn't grow that much. It'll get to maybe a foot, 14 inches in diameter, and then they'll cut it down and turn that into OSB.
So the product evolved to accommodate smaller trees. But according to Nathan, the hardware didn't. That's why he's not only replacing the biomass, he's reinventing the entire manufacturing process.
So the miniaturization part is just you take that and you make it much smaller. The output's going to be smaller, and then you're going to incrementally stand it up with more machines. The kind of compartmentalization and the modularization of it allows me to take those machines and place them very strategically with regards to biomass and where the customers are going to be demanding it. And then when you look at the electrification aspect of it, every aspect of it utilizes electricity. There's no natural gas, there's no using the biomass for fuel to heat or any of that.
The 5-year plan is to build at least 18 more machines like this one in farm-adjacent factories across the country. But what will it take to actually make that vision a reality?
Hardware is hard. If you don't develop it quick enough, you could very easily run out of money. Elon almost ran out of money with SpaceX. Same exact thing. That's effectively like your worst nightmare. You want to avoid that if at all possible. So there's that, and then ultimately we are setting up an entire supply chain of raw material from scratch.
Starting with securing the land itself. Planted says it's currently on track to manage 440 acres by the end of this year, with a goal to manage thousands more in the next several years. And that huge increase in supply will ultimately come down to the buy-in of farmers.
Farmers are notoriously cautious. You know, lots of them jumped into hemp and then couldn't sell it and lost a lot of money. So it is proving to them that we know how to plant it, we know how to harvest it, we can do all of that, that there's a steady source of income in this perennial.
Since it was founded in 2021, Planted has raised a total capital amount of $47.5 million. But with each production line costing roughly $5 million to build, and a goal of producing at least 18 to 20 of them by 2030, that's a spend of $100 million in hardware alone. Despite these hurdles, the company says demand isn't one of them. After signing its initial contract with D.R. Horton, the homebuilder upped that in 2024 to 10 million panels, enough to build 90,000 homes. The urgency makes sense. Stronger, more reliable material at stable prices, free from the volatile lumber market, and more affordable homes that keep demand and construction moving. But at Planted's current pace of 250,000 panels a year, it would take them 40 years to fulfill that order, which is why vertically integrating and scaling its operations is so critical. One way it's already doing that is through automation, specifically of its transplant operation, where these plant cuttings are picked up by this robot and then planted into their own individual plots of soil.
This whole thing is called the cutting edge, and it is running right now. Capacity is about 1,770 plants an hour.
That makes it 15 times faster than a human. The plan is to add one more arm to this robot and then set up another one just like it to 4x the speed. But in order to have enough cuttings for each arm to transplant, Planted will also introduce automation to its tissue culture lab, where 3 employees are currently dividing plant nodes by hand to multiply the grass faster than it would naturally in a controlled environment. Adding robots will not only speed up this process, it'll also prevent contamination.
If you get one cell of like bacteria in there, it's like a party in a jar. It has a grand old time multiplying like crazy, and that whole container of 20 plants is now contaminated.
And with a target of 20 million plants needed by 2028, there's no room for error.
Has anyone else done what you're doing?
They've definitely tried. They just weren't able to fully get there.
So you've like cracked the code.
Yeah, I would say so. I'll say we crack the code when we get to a point where we've got 20 machines and we've got the output capacity that I'm looking for. At that point in time, we can talk again. Until then, I'm still like, we're still, pencils up, heads down, and working pretty hard.
Yeah.
If this story resonated with you, go watch my video on Aptera, a solar electric vehicle company that was left for dead and then came back to completely reimagine what an EV could be. There's some disruption baked in there too. And if you know of another startup we should feature, drop a note in the comments. Don't forget to download our report on the 7 infrastructure businesses you can build in 2026. All right, see you guys in the next video.